Hello everyone, this is Dr.V.V. Kamesh, Professor of Mechanical Engineering, Aditya University, Surampalem. In this lecture, we will continue our calculations for the velocity finding in gear trains. The learning outcome for this lecture is, at the end of the lecture, student will be able to explain about the find velocity of the components in compound and epicyclic gear trains. Now look at the problem. The problem is given without giving the diagram, right. So, the problem is having some ideas, not only with the compound gear train, but also with epicyclic gear train also. Now, look at this, two shafts A and B are coaxial, okay, right. So, A is there, B is there, okay. So, this is gear A or shaft A and shaft B, right. A gear C, okay, I will take this one, okay. A gear C, 50 teeth is rigidly mounted on shaft A, okay, right. So, this is shaft A, gear C is mounted on it, okay, I will take, okay, I am taking, this is the gear C, right. So, one by one you need to add to the earlier data, right. So, shaft is there, gear C is mounted, okay, we completed. Next, a compound gear DE gears with C, okay. So, with the C there should be some one gear either D or E, we do not know, right, okay, and an internal gear G, okay. A compound gear DE gears with C and an internal gear G, right, okay. Now, there should be one compound gear DE, right. DE means another shaft is to be there, I am having two gears, right. So, gear D, gear E, right. So, one of the gear either D or E we do not know, right, at this point. Internal gear G, so internal gear G means there need to be one gear G, right. This will have internal teeth, okay, this is having internal teeth like this, okay, not exactly like this, just for your understanding I am drawing like this. So, this is internal teeth, okay. Now, D has 20 teeth and gears with C, okay. Now, out of DE, so this is gear D, right. Now, this is meshing with C, D has 20 teeth, okay, good one, and gears with C, and E has 35 teeth, okay. Now, I am taking, this is the compound gear and here I am having E, right. So, this is gear D, this is gear E, okay. Now, I have TD is given as 20, TC is given as 50, so number of teeth, right. E has 35 teeth, okay, right. TE is equal to 35. Now, E has 35 teeth and gears with the internal gear G, right. So, from other view, this is E and it is meshing with internal gear G, right. So, this is G, I am drawing with another color, the G, right. So, how it is meshing? How this is meshing? E has external teeth and G has internal teeth, right. Now, the gear G is fixed and is concentric with the shaft axis, okay, right. So, this is actually, now you can take the, okay. So, this is shaft, first shaft and this is the last shaft. These two are coaxial, right. What is coaxial? The axis of this one and this one axis is the same, right. On the same axis we are having two shafts, right. Gear G is annular gear or the ring gear, right? And it is driven by gear E. And what is the gear E? It is compounding with D, right? So D and E, they are on the same shaft. Now in the diagram you can identify very clearly, I am drawing all the shafts with the green color, okay, right. So this is shaft A, this is shaft B, right, okay. Now what is the extra data given? The compound gear D is mounted on a pin which projects from an arm key to the shaft B, right. So what is the support? So the compound gear D is mounted on a pin which projects from an arm key to the shaft B, right. So how the support for the D and E? So there is a pin and it is attaching, right. Sketch the arrangement and find the number of teeth on internal gear G. So I need to find TZ, right. Assuming that all the gears have same module. Why we are giving the word gears have the same module? Whenever we are going for the external meshing or internal meshing, whatever it might be, those meshing gears must be of the same module. So M. So the module of the gear is to be same. Otherwise, there will not be any meshing. It will be improper, right? If the shaft A rotates at 110 RPM, find the speed of shaft B. Okay, so this is the last one we need to identify. Up to this, up to the last line, we need to construct the diagram, then table, right? Okay, whatever you have drawn here, the gears shaft A and B, C is mounted on A and D is meshing with the C and D is compounding with the E and E is having meshing with G as internal teeth. Now G is mounted on B which is coaxial with the first gear. Okay, this is actually the data given for us. The number of teeth on gear C is given, D is given, E is given, but G is not given, right. Even then, we are able to find the number of teeth on G, right. Just you remember one thing, forget about this epicyclic gear train. When two gears are, two gears means first gear and the last gear, they are coaxial, in between there may be some gear train. In that case, we are finding the number of teeth based on one condition. What is the condition? The distance between the axis with the starting one, with the ending one, both are same, right. So the distance between the axis, right, we need to identify very clearly. Now you can look this. So C is meshing with the D, okay. So I am taking this. So this is my C gear. I am putting one color and C is meshing with the D. So now the D I am making with the one color. Now I am going back. The D and E, they are mounted on the same shaft. We are not giving any name for the DE shaft because it is not required for us, right. So D and E are on the same shaft. So concentric, when we are looking in the from other side, so from this side if you are see, whatever we are drawn here, it is of one view. You look from the other view, side view, right. So when you are looking from the side, centrally C will be there. C is meshing with the D and D is, what about the D and E? The number of teeth on gear D is 20 and E is 35. So E is the bigger one, right, but concentric with the D. So what I need to do? I need to draw E. Now I am giving some other color for D, right. So the D I am giving some, not D, it is E, okay. So DE, they are compound gear, DE is compounding, right. Now what about the last gear G? It is ring gear. It is ring gear, right? So ring gear means on the surface I am having, okay, I will give some other color, okay, better, some color, okay, right? So this is the ring gear. Now how I need to find the relation between C, D, E, G diameters so that I can find the number of teeth on gear G, right? Because some data is given, some other data is not given, right? Now you identify here. Now I am drawing one line, or otherwise you can draw easily, right? Now this line, what is this line actually? What is this? Radius of gear G, right? Now you look in the diagram. From here, I will draw with some other color here. So I can divide this into some parts. So this is one part, right? I am drawing some intermediate lines. Okay, up to this. Next, up to this. Then up to this. Okay, clear. Now from here to here, suppose I am saying this is 1, this is 2 and this is 3. Okay, what is part 1? Part 1 is radius of C. What is part 2? Radius of D. What is part 3? Radius of E. Okay. Like this, you need to identify the relation between the diameters of the gears or radii of the gears by looking at the diagram very carefully, right? So RG is equal to RC plus RD plus RE. Same to same, we need to transfer to the diameter. DZ is equal to DC plus DD plus DE, right? So the diameters relation is transferred to number of teeth, right? Then how do I find? TZ is equal to TC plus TD plus TE. So number of teeth on the ring gear will be 105, 50 plus 20 plus 35, right? So number of teeth is identified. Now you can go to the table, right? The table construction is very crucial and the first row is the most important one, right? Okay, this is the step, first column is 1, 2, 3, 4, 4 steps are there. Conditions of the motion, same thing. So start with the arm. Now how many gears will be there? Now here we are having, if you are treating separately, gear C is there, C, D, E, G, 4 are there, but D and E, it is a compound one, the behavior is compounded. It is binded by the same speed, right? Gear D, gear E, right? When speed is same, you need to look at DE as one set only one set, right? That means compound DE, that's it. Okay, so you should not call the compound gear to be gear E plus gear E, not like that. Compound gear DE, that's it. Sometimes you may write DE side by side without writing any hyphen in between, right? Compound gear DE, that's it. The name is DE only, right? So arm gear C is a unique one and compound gear DE, next gear G. Here we don't write anything related to whether it is epicyclic or sun gear or planet gear, nothing. Just simply the name C, D, D, G, that's it. So 3 components are there. Now starting with the first one, arm fixed, gear C rotates through one revolution. Okay, G. Gear C rotates with one revolution. What about the DE? You can look in this diagram. Because this diagram is with the different colors, you can understand how many meshings are there, how many energy transfer are there. So, C is meshing with D. So, I need to find ND, right? Relation ND by NC is equal to TC by TD, right? So, I need to find ND, right? So, here it is given ND is equal to minus TC by TD. Why it is minus? Reverse direction, right? Okay. Now, immediately I need to make it as equal to NE. Okay. So, for our calculation convenience, we need to write like that. Okay. So, ND is calculated minus TC by TD is equal to NE, right? Then, what about the gear G? Look in the diagram, G is driven by E. Even the early diagram also you see there. ND is calculated, it will become NE, right? Now, forget about D, C, A, everything, right? Now, you start your discussion with E. E is meshing with G, that's it. E is one gear, G is another gear. Now, get the relation between E and G, right? What is the relation? NE by NG is equal to TZ by TE, right? NG by or NG by NE is equal to TE by TZ, right? Now, NE already you know, I need NG. So, NG is equal to NE into TE by TZ. What is NE? Already you know, minus TC by TD. So, you substitute that. So, this part is actually NE. Multiply with the TE by TZ. Now, you can ask one question. When there is a relation between E and G energy transfer, why the sign is not reversed? Because E direction and G direction both are same. Got the point? Clear? That's why I am not making any negative sign before TE by TZ, right? So, once this first row is completed, the second, third, fourth will be automatic. What is second? Multiply all the components with X. Arm fixed gear C rotates through X revolutions. So, 0 into X plus 1 into X minus TC by TD into X, TC by TD into TE by TG with minus into X. Then add Y revolutions to all the elements because you are having one epicyclic gear train. So, there is an arm, you rotate all the components. Now, the total motion is, fourth one is always 2 plus 3. Then I got the relations for A, B, C, D. Okay. So, what is first one is for arm, for gear C, for compound gear. Next, this is for gear G. Now, you need to go back. What are the data given? So, TC, TD, TE, TZ, number of teeth for all the gears is a something is given and you find the TZ is equal to 105, right? Now, I need to have what is Y, what is X, right? What's the data given? You look back. The gear G is fixed, okay? So, the equation for the G should be made equal to 0, right? Any other data? Find the number of teeth on internal gear assuming that if the shaft A rotates at 110 RPM. So, shaft A data is given. Now, what is shaft A? Gear C, right? So, this one the data is given 110 RPM plus and gear G is fixed. When it is fixed one, you make it as equal to 0. So, I am having the two equations. One is x plus y is equal to 0, right? So you can make x is equal to minus y, okay. Substitute this x is equal to minus y, okay. Here also it is there. Y minus x into Tc by Td into Te by Tc equal to 0. So y is equal to x into minus x into, not minus, it will become plus Tc by Td into Te by Tc. So in place of x, I can make minus y. Then finally I got, yeah, x plus y is equal to 100 here. No, not actually 0. It is 110. Yeah, x plus y is equal to 110. X will not be equal to minus y, right? So two equations, x plus y is equal to 110 and y minus x into Tc by Td into Te by Tc is equal to 0, right? So solve the two equations, I will get x is equal to 60 and y is equal to 50. Thereby I can find the shaft of B will be equal to plus y. The summary of this lecture is, student can calculate the velocities of the components of the compound and epicyclic agents under given conditions. Thank you.